Infinity is a weird concept, but it comes up a lot in astronomy, and now we have an infinity galaxy. Here's a JWST image of the galaxy, and just in case your memory of mathematical symbols is a bit rusty, I'll overlay the symbol for infinity for you. Astronomers have used a combination of JWST, Hubble, a spectrometer on the Keck 1 telescope, radio data from the VLA, and X-ray observations from the Chandra X-ray Observatory to study this galaxy in detail. It appears to be the result of a face-on merger between two disk galaxies, and the shape is not the oddest thing they discovered. What really caught their attention was the fact there appears to be a supermassive black hole located here, in between the two massive galactic cores that you can see here and here. Generally, we find black holes in the centers of galaxies, so finding one in this location is surprising. If all that wasn't surprising enough, we seem to have caught this black hole just after it's formed, which is totally shocking. One way black holes can form is when massive stars collapse at the end of their lives, creating the black hole, which then grows by accreting material from its surroundings. Supermassive black holes may then form when smaller black holes merge with each other. Something very different seems to have happened here. The supermassive black hole seems to have formed by the direct collapse of a huge gas cloud with no star being involved in the process. One idea to explain this is that the two disk galaxies collided almost face on and formed the ring-like structure that looks like the infinity symbol. The gas trapped in between the two cores was then compressed into a dense cloud that collapsed to form the black hole. Looking at the brightness of the black hole at different wavelengths, we can also tell that it's busily accreting huge amounts of material from its surroundings. This direct cloud collapse model of black hole formation is not new, but now we have actual observations of a black hole formed this way just after it was born, which is really exciting. This is an amazing result, and a lot more research will be needed to get to the bottom of what's actually going on here, including the development of theoretical models and computer simulations that can reproduce the features we see in the image. JWST often simply has too full of a schedule to do follow-up on its many discoveries, and this is a great example of a finding by JWST that's led to follow-up work from different observatories on and off the Earth at multiple different wavelengths. As always, I am glossing over a lot of details here, and the paper was published in the Astrophysical Journal Letters on July the 15th, and there's a link in the description. That's today's video. Please like and subscribe, and I'll see you in the next one.